This tutorial shows how to interpret dummy variables in a linear regression in SPSS. I will use the following example. For a hypothetical dataset, I want to explain the income with two categorical variables only: gender, male or female, and the person's highest achieved degree, none, bachelor's or master's. Gender is naturally dummy coded in this dataset. Degree requires creating dummy variables beforehand, which I have shown in an earlier video linked in the description. Each value gets its own dummy variable with 0 and 1, indicating the presence or absence of the respective value. To calculate a linear regression with dummy variables, go through Analyze, Regression, Linear. As usual, the dependent variable is assigned. For the independent variables, I will enter gender first, since it is naturally a dummy. Let's enter degree into the model. I have 3 dummies, but only need 2. If I have information about the presence or absence of a degree in 2 of the 3 categories, the third one can be derived from that information. Hence, if you enter all dummy variables, SPSS will remove 1 dummy automatically. It is therefore recommended that you leave 1 dummy out. More precisely, the reference category or reference group. If I want to see the difference between the income of people with a bachelor compared to no degree, or masters compared with no degree, I will waive the dummy variable representing no degree. Hence, only the dummy variables for bachelor and master are entered into the model. The interpretation is straightforward. I will ignore in this video the f-test and model fit and only focus on the coefficients table. Let's start with the gender variable. The reference group for naturally dummy coded variables is the lower value. In my example, male is coded with 0 and female with 1, which makes male the reference category. The coefficient of gender is therefore the difference between the reference category, here male, and the other category, female. Compared to the reference category male, the female participants of this survey had a lesser income of 191 units. However, the p-value is not low enough to reject the null hypothesis for the gender variable. Let's look at the degree now. I left no degree out. The coefficient 515 is the amount of income that a person with a bachelor's degree has more than a person without a degree. In a similar way, 829 is the amount of income a person with a master's degree has more than a person with no degree. Both p-values can be considered low enough to reject the null hypotheses. What if I wanted to see the difference in income between bachelors and masters? You simply waive the other dummy, let's say the bachelors. The f-test, model fit and all parameters of the other variables will remain the same with the recalculation. The coefficient for none and masters will now show the income difference with the reference category bachelors. A person with a master's has 314 more income than a person with a bachelor's. P is not sufficiently low though. None compared to bachelor shows minus 515. This is exactly the opposite amount we observed earlier for the bachelor's degree when none was the reference category. Finally, we can swap the reference category for a third and final time, waiving the master's degree. The coefficients are all carrying negative signs and show the differences in income between masters and bachelor, minus 314, and masters and none, minus 829. We were already able to observe in earlier calculations. Please always consider the p-values when making those comparisons.